Hello everyone. Welcome to Embedded System course. In previous lecture, we started with chapter number 2, that is 8051 timers and serial port programming in C. So we saw contents of this chapter. There are two parts. First one is 8051 timer and second part is serial port. Okay. So first we will study in part 1 8051 timer programming in C, and in second part we will study that is programming serial port of 8051 in a C. Okay. So we started with part number 1 in previous lecture, that is lecture number 1 of chapter number 2. Okay, and we started our discussion on introduction to 8051 timers. So there are two timers, timer 0 and timer 1. Okay, and these timers we can use to generate time delays, or we can use these timers to count events that are happening outside 8051. That means we can use timers as counters. Okay. uh, so to use these timers, there are SFRs associated with timer 0 and timer 1. Okay, so these SFRs are Tmod SFR, that is to configure these timers, timer 0 and timer 1, I can use this Tmod. Then Tcon SFR to control the operation of these timers, timer 0 and timer 1. There is one SFR that is called as Tcon, that is timer control SFR. And timer 0 and timer 1 are associated with its own timer registers, that is TL0 and TH0, that is for timer 0 16-bit, and TL1 and TH1 for timer 1, again it is also 16-bit. Okay, so then we saw the formats of this Tmod and Tcon. Okay, so by using Tmod we can configure timer 0 or timer 1 either in 4 modes: mode 0, mode 1, mode 2, and mode 3. Okay, and then we especially saw the block diagram of mode 1 and its operation. Okay, so mode 0 is very rarely used. It is 13-bit mode. While programming for 8051 timers, we will directly move to mode 1. Okay, so all these things we studied in previous lecture, and now we are moving towards next lecture, that is lecture number 2, in which we are going to study programming 8051 timers in a C for time delay generation. Okay, especially by using mode 1. First, we will see how to generate time delay, what are steps involved in time delay generation using mode 1. Then we will see calculation of initial values to be loaded into TLX and THX registers, means either TL0, TH0 or TL1, TH1 registers for a desired time delay. Okay, and then we will see the significance of gate bit from Tmod SFR. So in Tmod SFR, out of this Tmod SFR, lower 4 bits are used to configure timer 0, upper 4 bits are used to configure timer 1, and for each timer, that is timer 0 and timer 1, there is a gate bit. Okay, so what is significance of that gate bit? Very briefly we saw in first lecture. Okay, but we will see in detail what is significance of gate bit. So these are the points on which we will discuss in this lecture number 2. So first point, that is time delay generation using either timer 0 or timer 1 in mode 1, which is 16-bit mode. Okay, so these are the steps involving programming steps for time delay generation using timer 0 or timer 1. Okay, so first load the Tmod register with value indicating which timer is to be used and which mode. Okay, so first, by using Tmod register, we have to decide which timer, either timer 0 or timer 1, we are going to use and in which mode. But here especially we are saying mode 1, so accordingly we have to load value into Tmod register. Okay, to configure either timer 0 or timer 1 in mode 1. Then load initial count value that is calculated for a desired time delay. Okay, in a TLX and THX, means either TL0 and TH0 or TL1 or TH1, depending on which timer, that is timer 0 or timer 1, you are going to employ to generate this time delay. Okay, next tip is after loading TL TH registers and after configuring um, timers in mode 1, we have to start the timer. Okay, using TRX, means either TR0 or TR1, depending on which timer you are using, and that bit is from TCON SFR, that is timer control SFR. Okay, so we have to set this bit either TR0 or TR1 to start the timer. Okay, so after timer starts, count in a TL and TH register will start counting up due to each pulse it is getting from timer clock frequency, which is generated from oscillator frequency. Oscillator frequency will get divided by 12, and that frequency pulses are used to increment the count in TL and TH register. And when this will happen, when you set this TR bit, okay, means you start the timer, then these pulses will start reaching to this timer register, and count in this timer register will start incrementing by 1 due to each pulse it is getting. Okay, then after that your job is just monitor TF flag bit, timer flag bit. TF means timer flag bit. So TF0 or TF1, depending on which timer you are using, you have to monitor, and that TF bit is in a TCON. That is TF0 and TF1 bits are in TCON. Okay, so you have to just keep monitoring to see if it is raised, means if it is set. Okay, so when this TF flag bit will get set, when count in TL and TH register rollovers from all ones to all zeros, that is F to 0 0 0 0. Okay, so when this happens, this TF flag bit will get set and you have to get out of loop. Okay, then you have to stop the timer by resetting TR bit from TCON SFR, then clear TF bit. Okay, because it was set due to rollover of count in timer registers. Okay, you have to clear this TF flag bit for next round, that is to again go on generating time delay by using same timer. Okay, again for that you have to go back to step 2, that is this step. Again you have to load this step number 2. You have to load TLX and THX with again some initial count value, okay, to generate a desired time delay. Okay, so these are the steps involving time delay generation either by using timer 0 or timer 1 in mode 1. Okay, now this is T mode as I told you. So upper 4 bits are used to configure timer 1 and lower 4 bits are used to configure timer 0, and this is gate bit. Okay, and these are M0 M1 bits used to configure timer 0 or timer 1 either in mode 0, mode 1, mode 2, mode 3. Mode 0 is 13-bit timer mode, mode 1 is 16-bit timer mode, mode 2 is 8-bit auto reload, and mode 3 is split timer mode. We are now studying this mode 1, that is 16-bit timer mode. Okay, uh, now now how much time delay that will get generated by timer 0. So here not timer 1, timer 2, timer 0 or timer 1. If a initial count is loaded into timer uh, registers. Okay, so here I will just uh, read this example. Calculate the amount of time delay in the delay subroutine generated by the timer assuming crystal frequency is 11.0592 megahertz. Okay, here I will use pen now. Okay, so what आपल्याला काय करायचं आहे तर so okay, so we are going to calculate delay generated that will get generated by either this is timer 0 or this is timer 1. Okay, so for that FOSC, that is 11.0592 megahertz. Okay, and here initial value loaded into timer register, that is either THX or TLX, here assumed as FF2, means FF is loaded into TH register and F2 is loaded into TL register. Then what will the time delay that will get generate by using this timer 0 or timer 1? Okay, now FOC, for that I will refer to the block diagram of um, timer 0 or timer 1 in mode 1. Okay, so here what is given? Here crystal frequency is given. So I will enable pen here. So here this frequency is given FOSC, that is equal to 11.0592 megahertz. And again what is given? These resistors are loaded with initial value FF F2 in TH and TL, means either TH0, TL0 in case of timer 1 and TH1 or and TL1 in case of, this is in case of timer 0 and this is in case of timer 1. Okay, suppose I am using timer 0, so F oscillator, that is pulses we are getting here at the output of crystal oscillator, that is 11.592 megahertz, and these these pulses will get, or this frequency will get divided by 12. Okay, so what is the frequency of these pulses? That is equal to 11.0592 divided by 12 megahertz. Okay, and if we calculate the time period of these pulses, that is this period of one pulses. Okay, so you have to just make it as 1 divided by 11.0592 megahertz divided by 12. If you calculate this, it will be 1.085 microsecond. Okay, means in one in this time 1.085 microsecond I will get one pulse here. Okay, now assume this is as a TR0, this CT bit from T mod. Okay, CT bit of timer 0, we are assuming timer 0. Okay, so now as the steps given, these TH and TL are loaded with initial value. Now what should be done? We have to start the timer. How to start the timer? You have to make this TR0 bit, which is in TCON. Okay, we have to make it set. Okay, when we make this TR0 bit set, what will happen? The pulses at the other input of this AND gate. So this is AND gate. Okay, so this AND gate will be enabled only when this input is set. When this input is set, this pulses starts reaching at the output of this AND gate. Okay, once this pulses starts reaching at the output, means it is these pulses starts reaching to these timer registers. Count in these timer registers start incrementing. And how it will increment? It will increment by 1 due to each pulse of these clock pulses. Okay, now these pulses are called as, or this frequency of pulses are called as timer clock frequency. Timer clock frequency, which is F oscillator divided by 12. Okay, so this timer clock frequency pulses starts reaching and it will increment count in TH and TL register after each pulse. Okay, that means in this 1.085 microsecond, count in TH and TL will get incremented by 1. Okay, means due to first pulse, what count will become? It will become FF, FF, F2, F3. It will get incremented by 1. Due to again next pulse, it will become F3, FF, F3. Okay, so after how many pulses, this count will become maximum, that is F, 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 F. I think that is a F, this we can calculate by using f minus f2, where f2 is the initial value loaded into timer register. Okay, and I think this value becomes decimal 13, means after 13 pulses count in TH and TL register becomes FFFF. Okay, so after starting timer, what is our job? Our job is to monitor this TF, that is now TF0, because we are using timer 0. Okay, so when this TF0 flag bit will get set, when count in TH and TL register rollovers from all ones, means FFFF to 0 0 0 0. When this will happen? So this will happen after 13 clock pulses. The count in TH and TL becomes FFFF, and due to one more clock pulse, means 13 plus one more clock pulse, what will happen? This count now becomes maximum, and if we add 1 into it, what will happen? This count in TH and TL register will become 0 0 0 0. So this value is changing from maximum to minimum. Okay, that is FFFF to 0 0 0 0, means all ones to all zero. This is called as rollover of count in timer register, and when this happens, this TF flag bit will get set. Okay, then we have to stop, and we have to come out of loop. We have to stop this timer, means we have to make it 0. We have to clear this TF0 flag bit, and we can go back to again using this timer. Okay, so this initial value loaded, initial value loaded in TH and TL register will decide how much time delay that will get generated. Okay, right now here, how much time delay will get generated? 13 plus 1 pulses means 14 pulses, and for each pulse, how much time is required? 1.085 microsecond. Okay, 1.085 microsecond, and that time will be actually 30 point, that is 14 into 1.085 microsecond, 15.19, that is 15.19 microsecond. 15.19 microsecond. This is the time delay that will get generated. Okay, by this timer 0, when we load initial value f2 into timer register, and crystal frequency used is 11.0592 megahertz. Okay, now this calculation, for this calculation we can derive a formula that will calculate how much time delay that will get generated. Okay, so here is the formula given in hex. So that formula is f minus xx plus 1 multiplied by 1.085 microsecond. Okay, so f is the maximum value, and minus xx is the value in hex loaded into timer register, that is TH and TL register, plus 1, because one more pulse is required to roll over the count from all ones to all zeros, and multiply by 1.085 microsecond, which is the time period of timer clock frequency, which is equal to f oscillator divided by 12. Okay, and if we convert this formula in decimal, that will become 65536. Actually it will become 65535, which is equivalent of ff. So I will write formula here, fff in hex minus yxx plus 1, and this is multiplied by 1.085 microsecond. So if I convert this fff to decimal, it is 65535, minus if I convert this, okay, to decimal, then I will write n like, okay, which is decimal equivalent of yxs plus 1, remaining part is same, 1.085 microsecond. So that is equal to 65535 plus 1 means 65535 minus n. Okay, and this is multiplied by 1.085 microsecond. So this is the formula, 65536 minus n multiplied by 1.0. So this formula you can use to calculate time delay that will get generated by timer 0 or timer 1 if we use it in mode 1, and where YY axis is the initial value loaded in timer register TH and TL register in hex. Okay, and N is the that value in decimal. So this formula is in decimal, this formula is in hex. Okay, in this way we can calculate the time delay that will get generated. Okay, now reverse procedure. For example, if the desired time is given, then what are the steps to determine the value, initial value, okay, to be loaded into TL and TH register, TLX or and THX registers of timer 0 and timer 1, assuming that crystal frequency is 11.0592 megahertz. Okay, so first, suppose desired time delay is TD, time delay TD in seconds. Okay, then first step is what? Divide this TD, time delay in seconds, by 1.085 microsecond. What value I will get? I will get value n in decimal. I have to just divide that desired time delay you want to generate by using timer 0 or timer 1 by 1.085 microsecond. And how it comes 1.085 microsecond? This crystal frequency, that is FOSC, if we divide by 12, that will act as timer clock frequency. Okay, and its time period, okay, means reciprocal of this, means if we 1 divided by f oscillator divided by 12, if you calculate this, assuming f oscillator 11.0592, it comes 1.085 microsecond. So this is 0. Okay, so first divide this desired time delay by 1.085 microsecond, which comes and assume, then perform this arithmetic. Okay, 65535 minus n plus 1. So we are using formula in decimal. Okay, so where n is the value we have got in step 1. Okay, so after that, convert the, in step 3, convert the above result. So whatever value in decimal we will get after the calculation of this formula. Okay, so convert that result we have got in step 2 to hex, and if we assume that result we have got YYXX, so that is the initial value to be loaded into timer register. Okay, so XX will be loaded into lower timer register, and YY, that is higher byte, will get loaded into TH register. In this way, we can perform calculations in 4 steps to find out the initial value to be loaded into timer register for a desired time delay to be generated by using timer 0 or timer 1. Okay, so all these calculations you are going to do while programming to generate time delay by using timer 0 or timer 1. Okay, now one more example to calculate the values to be loaded into TLX and THX register. Assume crystal frequency is 11.0592 megahertz. What value do we need to load the timer register if we want to have a time delay of 1 millisecond? Okay, now here, according to these steps, I will perform calculations. So I will use pen. So where is pen? Okay, so in step 1, so it is not working. Okay, so in step 1, okay, so what I will do, I will this time delay given is so time delay given is 5 millisecond. Okay, 5 millisecond. So in step 1 I will, so this 5 millisecond, okay, I will divide by 1.085, 1.085 microsecond. Okay, so let me, whether this pen is working. Pen is not working. Okay, so first I will divide this 5 millisecond by 1.085 microsecond. Okay, so as in this formula, first I will divide this delay, that is 5 millisecond. So TD is 5 millisecond. So I will divide that by 1.085 microsecond because crystal frequency is 11.0592. So I will get some value n. Okay, so what value I will get? So after that, 5 millisecond is divided by 1.085 microsecond, I will get 4608. Okay, so then I will put that value here. Okay, in this formula, that is 6553 minus, what is that value? That is 4608. So 65535 minus 4608 plus 1. So that value I will get. Okay, if I convert that value, decimal value, into hex, I will get EE00. Then what is the initial value you should load into TH and TL register? You should load 00 in TL register, and you should load EEH into TH register. Okay, of either timer 0 or timer 1. In this way you can do calculations. Okay, so in this way we can program timer 0 or timer 1 in mode 1. Okay, to generate time delay. Okay, so very important part is to calculate the initial value to be loaded into TL and TH register to generate a desired time delay. Okay, so next part and last part of this lecture is significance of gate bit. Okay, so this is just block diagram of timer 0 or timer 1. Okay, so we studied this block diagram. Okay, so that block diagram is detailed block diagram when we use gate bit. Okay, so this part is actually um, that is this part up to this gate bit. Okay, when we use gate bit, okay, then this internally this block diagram changes like this. Okay, so this is gate bit, actually this bit is a gate bit. Okay, so still it is not working, pen is not working. Okay, okay, so what is significance of gate bit? So where is gate bit? It is in T mod. Okay, so every that is timer 0 and timer 1 both are having gate bit. You can uh, see here, this gate bit is for timer 1 and this gate bit is for timer 0. So what is significance of this gate bit we are studying? So if normally that gate bit is 0, okay, but if we make gate bit 1, that means we can control the operation of that timer, either timer 0 or timer 1, externally. Okay, and how we can control that? Means control the operation of timer means turning on or off timer. Okay, normally we turn on or off timer by using this sorry. Okay, so for that we use this TR bit, either TR0 bit or TR1 bit, which is in TCON. Okay, timer run bit. Okay, if we make this bit 1, timer will start, means it will close this switch, means this is actually AND gate. Okay, so these pulses we are getting either from the internally generated from oscillator frequency, that is F oscillator divided by 12, or if we are using this timer in counter mode, we are going to count these pulses we are getting from outside 8051 via pin 3.4, that is a T0 pin for timer 0, and in case of if we are using timer 1, this T1 pin, that is pin number 3.5, that is port 3 pin number 5, port 3 pin number 4. Okay, so if we are using timer 0, this pin will be 3.4, that is T0 pin, and if we are using timer 1, means this pin is 3.5, port 3 pin 5, that means T1 pin. Okay, so when we are configuring timer in counter mode, this switch will be connected here and it will count pulses from outside 8051. Okay, and these pulses will start reaching at the output. Okay, and will be counted in timer register only if this gate bit is on. Means if it is on, then only these pulses starts reaching at the output and will be counted in timer registers. Okay, and this switch or gate, AND gate, is being controlled by output of this AND gate, and this AND gate is controlled by this TR bit. Okay, and other input is from output of this OR gate, and input to this OR gate is gate, that is a bit from tmod, and int 0 pin in case of timer 0. Okay, or int 1 pin in case of timer 1. Okay, means timer 0 and timer 1 can be operated or controlled from outside by using pins int0 and int1, which are interrupt pins. int0 is interrupt 0, external hardware interrupt 0, and int1 pin is external hardware interrupt 1. Okay, now if this gate bit is 0, okay, if this gate bit is 0, then output of this OR gate will be always 1. Means this gate, okay, AND gate will be controlled by only TR1 bit, TR0 or TR1 bit. Okay, means if this bit is 0, output of this AND gate will be 0, and this switch will be off and timer will be off. Okay, and if this bit is 1, then irrespective of this other input, output of this AND gate, always this will be 1, because gate bit we have assumed 0. So this is inverter, so at the output I will get 1. So output of this OR gate will be always 1 if gate bit is 0. So this AND gate is under the control of this TR bit. Okay, if TR bit is 0, then output of this AND gate bit will be 0. This gate will be off, means these pulses at this input will stop reaching at the output and timer will be off. If this TR bit is 1, then output of this AND gate will be 1, and it will enable this gate, and whatever pulses it is getting at the input, that will start reaching at the output, and it will increment the content in timer register, and that means timer is on. Okay, so when gate bit is 0, this timer on and off control operation will be controlled by this TR bit. Okay, now suppose this gate bit is 1, then the output of this will be 0. Okay, now output of this OR gate depends on what is input, other input, int0 or int1 pin input. If this is 0, output of this uh, output of this will be 1. Okay, so sorry, it is now 0, output will be 0. Means if int 0 in case of timer 0, if we are using timer 0, then int 0 pin will be used, and if it is 0, output of this OR gate is 0. Since one input of this AND gate is 0, output of this AND gate will be 0, and timer will be off, because this AND gate is disabled. These pulses at this input will not start reaching at the output, and that means timer register is not counting these pulses, because these are not reaching at the output. This gate is disabled due to output of this AND gate is 0. Now if suppose this int0 is 1, gate input is 1, int0 is 1, what will happen? Here output is 0, here that is input of this OR gate is 0, and this input of this OR gate is 1, so output of this OR gate is 1. And now if this is the case, then this input is to this AND gate, and other input is TR bit. Now if TR bit is 0, output of this AND gate is 0, and this gate is disabled, means timer is off. Okay, now if this TR bit is 1, what will happen? Other input is also 1, and now this gate will be enabled, and pulses here starts reaching at the output, means timer is on. Okay, means now here by using int0 pin and tr0 pin, okay, I can control the operation of timer 0. Okay, that means I can, even if timer, this tr bit is 0 or 1, and if this bit is int0 input is 0, if gate bit is 1, means timer will be always off. We cannot control timer by using simply this TR bit. Okay, means when this gate bit is 1, then by using int0 pin and tr0 pin in case of timer 0, we can control the operation of this timer 0. That means we can turn on or off timer by using both this int0 and TR0 bits. TR0 bit is internal and INT0 pin is internal, on which we can input either 0 or 1. Okay, and that means now we are controlling the operation of timer 0 externally by using INT0 pin. Okay, and internally by using TR0 pin. Okay, so when gate bit is 1, the start and stop of the timer can be done externally through pins P3.2 and P3.3, that is INT0 and INT1 pins for timer 0 or timer 1. Okay, so not only by using INT pins, we need also TR pins. Without TR pins, we cannot turn on or off timer 0 and timer 1. Okay, in this way, by using gate bit, we can externally control the operation of either timer 0 or timer 1. That means we can externally we can use INT0 and INT1 pins to control uh, the operation of timer 0 and timer 1, that is turning on or off timer 0 or timer 1. So this is significance of gate bit. Okay, so in this way, in this lecture, we studied the steps involving that is time delay generation using timer 0 or timer 1 in mode 1 in C programming language. Then we saw how to calculate the delay that will get generated by timer 0 or timer 1 when some initial value is loaded into timer registers. Then we saw the block diagram of timer 0 or timer 1 in mode 1, and we actually discussed the operation, what exactly happens when initial count is loaded and timer is started, and how whenever roller of count happens, this TF flag bit will get set. Okay, and um, we derived the formula to calculate the time delay that will get generated. Okay, in both, that is hex and uh, decimal. And then by reversing that formula, we can calculate the initial count value to be loaded into TL and TH register for a desired time delay. Okay, so there are 4 steps that we discussed. Okay, we took one example, that is for 5 millisecond, what is initial value to be loaded into timer 0 timer registers, uh, that is of timer 0 and timer 1. And then we saw the significance of gate bit. Okay, so if any doubts, we can discuss in our live session, you can ask. Okay, so we will stop here.